Hello everybody, we are doing our last day of notes for Unit 3, and these notes are on how to create an equation for a function, as well as finding like f of x, which basically means like they give us the x or the y and we have to plug it in and find the other part of the ordered pair. So, let's go ahead and get started. I'm not even going to make a big screen because I'm going to have to write on this because it doesn't have as much stuff as I'd like it to. So I will be using my little marker. Don't make fun of the fact that I can't write because I'm doing it with the mouse. So yeah, let's go ahead and get started. So creating an equation for a function. When we make an equation for a function, we're basically looking for, didn't click, patterns, okay? We're looking for what is going on between the x and y. What pattern is emerging when you see all this stuff in a table? Okay, you want to ask yourself what must be done to the x value in order to get to the y value. Okay, because the y value is going to depend on the x. So like basically, I can't remember if I showed you what a function machine is in class, but here I'll draw a little picture. Okay, ooh, it's just like a box, and then it's got like a funnel thingy where you can throw things in. Oh. Yeah, this video's gonna be long just because I'm drawing things in it. So it's like the x goes in. Ooh, yeah, there we go. And what comes out is your y value. Okay? And sometimes it's got it is an equation that you do to it. Okay? Whatever f of x is equal to, that's the equation you put your x in, and it will give you your y. That's an arrow, by the way. Trying to make it pretty on a computer, that's hard. Okay. So that's a function machine. So when I talk about it, that's what I'm talking about. Basically, you have to put an x in, change it up a bit, and then you get your y. Okay? So here's an example. We got a table. We want to look at what's happening. Okay? The best place to start is to look when x is 0. Okay? What did they do to x when it was like there wasn't anything there to get to the y value? Well, here they didn't do anything to it because it stayed 0. So that means nothing got added to it or subtracted to it for sure. However, something could have been multiplied by it. So we move on to the next part. Well, what did I do to 1 to get 1? Nothing. So I want to move on to something else. What could I do to 2 to get 8? What could I do to 3 to get 27? And that's something that I do to all my x's has to be the same across the table. Okay? So what can I do to 2 to get to 8? Well, I could multiply it by 2 and then multiply it by 2 again, but that won't work for 3 to 27. I can't multiply 3 times 2 and then multiply by 2 again. It won't give me 27. Okay? To get 8, I could multiply it by itself 3 times, so basically meaning cube it. So if I did a little cube here, ooh, that's a 3. A cube to 2, I'd get 8. If I cube 3, would I get 27? I would. So it works for these. If I cube 1, will I get 1? Yeah. If I cube 0, will I get 0? Yeah. If I cube negative 1, will I get negative 1? Yes. If I cube negative 2, will I get negative 8? Yes. Okay? So because it's the same thing that's happening to each ordered pair, same pattern, that's the equation. In order to get to y is going to equal whatever the cube of x was. Okay? So if I cube x, I'm going to equal the y. Okay? This is one of the more difficult ones. So another way you could have looked at it is like, okay, well, all the y's are perfect cubes, and the x's are the cube roots of those perfect cubes. So if I cube x, I'll get y. Okay? You're going to try this one on your own. Okay? Remember to start with when x is 0. What happened to it? It went up to 1, so it looks like you added 1 to it. Okay? Knowing that, what else might have happened to it? So try this equation on your own. We'll go over the answer next class. Okay? So pause the video, try this one on your own. Okay. So you should have an equation now. You could have put in f of x equals or y equals, doesn't matter. So let's go on to the next one, which still deals with patterns. However, sometimes we don't need the equation. Sometimes we just need to fill in the pattern. Oh my goodness, sorry, I'm fiddling with my watch and it's really hard. Don't know why. And you're gonna be so excited. I got it! It fixed my watch. My watch? Okay, my watch. It's done. Alright, moving on. Come on, Miss Scully. Sometimes we have to complete the pattern without an equation. So sometimes we'll just get a table and oh look, there's a missing number in it. So we still have to figure out what the pattern is, but we don't actually have to write it out algebraically. We just need to do that pattern. Okay? So we're still starting where x is 0. Okay? It went up, the y is 3 when x is 0, so that means I have to add 3 to the x value, but that might not be enough, because look, if I add 3 to 1, I don't end up getting 2. If I add 3 to 2, I don't get 1. So something else is happening. Okay? I know I'm going to have to add 3 because that's the only way to get this one. But something else happens. It looks like, okay, the way you could do it, because you know you're adding 3 to everything, just work backwards. Subtract 3 from here. You get negative 1. Well, what do you have to do to 1 to get negative 1? I have to multiply it by negative 1. So maybe I'm multiplying the x by negative 1 and adding 3 to it to get my y. Let's test that theory. Negative 1 times 0 will give me 0. And add 3 to it, I get 3. Negative 1 times 1 gives me negative 1. Add 3 to it, I get 2. Okay? So we can ignore this negative 3. Okay? If I multiply 2 by negative 1, I get negative 2. Add 3 to that, I get 1. I multiply 3 times negative 1, I get negative 3. Add 3 to that, I get 0. If I multiply 5 by negative 1, I get negative 5. Plus 3 gives me negative 2. So that works. Negative 1 times 6 gives me negative 6. Plus 3 gives me negative 3. So all of that works. So that's the pattern. That's basically the equation too. Multiply the x by negative 1, then add 3 to it. So here we have 4 times negative 1 would give me negative 4 plus 3. That means I am going to get negative 1. Okay? We will go over this stuff so much more in depth in class, okay? So don't worry. We will keep going over it. Oh, look, I did have plus 1 there. Oh, wait, that was your answer. Oh, well. So this one you're going to try on your own, okay? Starting with x, when it's 0, nothing happens to it. That means nothing got added to or subtracted to the x. So you're looking probably at what got multiplied or divided to get your y's. So what'd you multiply x by to get y? What'd you multiply x by to get y? So think about that, and then fill in the question mark. We'll go over this answer in class, okay? Okay, moving on to page 2. Alright, so you have all this already. Remember, function notation, that means that it's a function, okay? This little x in here, that's your input value, okay? That's the x value that you put into the machine. And f of x, which we said was the same thing as y, is your output. So whenever you see f of x equals something, that means your output is that. There you go. But when you see f with a number inside the parentheses, that's your x value. So that's what you want to plug in for x. But if you see f of x, that exact same thing equals a number, then that means that's what your y value is. That number is your y value. Okay? So here's an example. We have f of negative 3, or it says find f of negative 3 if this is your function. This is the equation we're going to use. Well, we know the x value now, so I'm going to plug in the x value for this x. Okay? F of negative 3 means that I'm plugging in negative 3 for the x. Now I just go ahead and simplify. Negative 3 squared is 9. So 9 plus 4 gives me 13. So f of negative 3 is equal to 13. That's my answer. Okay? That's what I'm doing. B, find x when f of x is 5. So they told me the y value. And here's the equation. So I'm going to replace f of x with a 5. And then I'm going to find what x is, which is what they asked me, by solving for x. So I'm going to add 6 to both sides. 6's will be gone, so I get 11 equals 2x. Divide everything by 2. I end up getting x equals 11 over 2, or 5.5. I think, yeah, 5.5. So that's my answer. So it's really just about substitution and making sure you understand where you're substituting it for. Okay? C. So here it is. Okay, A and B were algebraically. Graphically, it's just looking around and seeing what it is. Okay? Find f of -5. That means they gave us what the x was. We need to find what the y was when x is -5. So what we're doing is we are going to look where x is -5, right here. And we're going to go up to the graph at that point, right here. You guys all see that? Yeah. Oh, it looks like a little heart. Right here. Okay? That's where x is -5. The y value there is 1. Okay? So f of -5 is equal to 1, because that's the y value is 4. Okay? D, they want you to find f of x equals 6. So we're looking for the x value when the whole thing equals 6. So what we're doing, again, like I said, we're looking for the x value, but we know that y is equal to 6. So we're going to go to where y equals 6, right up here, and we're looking at this x value. Okay? The x value is 0 at that point. Okay? So f of 0 is equal to 6. X equals 0. Okay? Now you're going to go ahead and try these on your own. These 4 on your own. We will go over these next class. But remember, it's just about plugging stuff in and solving for it. Okay? So here, they gave you the x. So plug that in for the x here. Here, they gave you what y was. So you're going to replace f of x with that and solve for x. Okay? So go ahead and try those on your own. When you come back, we'll move on. Okay, moving on. Actually, yeah, so that's it for regular algebra. You guys are done. Honors, we got a couple things to talk about. So regular algebra, if you want to keep watching, feel free. We're going to talk about interval notation, which is an honors topic, but we actually aren't going to use interval notation in honors until inequalities. Just thought I'd show it to you now. And we're going to talk about finding f of x, or finding x when it's not just equal to a number, it's equal to an expression. So anyone's welcome to watch, but honors, you are the ones that have to watch because it will be on your test, okay? Except interval notation won't be. So interval notation is basically another way of writing your domain and range, basically. So instead of using inequalities in our domain and range, interval notation just uses the smallest and biggest number, and that's it. So instead of writing this, which is what we've all seen, this is set builder notation, all we have to do is write that. So it's literally the smallest number and the biggest number, and then we use a comma in between them, and we either use a bracket or parentheses to tell us if we're equal to or not, okay? Parentheses tell us that we're not equal to that number, so same reason why we use less than, we use parentheses around the infinite sign, because we don't actually equal infinity, okay? So that would have a parentheses around it, meaning it's not included, it's not equal to. Brackets are used when the numbers are included, or they are equal. So because we did have something on -4 here, since we're equal to -4, or we could be equal to -4, we have a bracket around the -4 showing that it is included in this interval, okay? Your first number is always your smallest, just like with set builder, and your second number is the biggest, just like with set builder. That's interval notation. We will practice this more when it comes to inequalities, but this will not be on your test, so don't worry about it. All you need to know is set builder for your test. But I thought it's a good place to introduce it because we are talking about these domain and range. So I just wanted to show it to you. This next part will be on your test, okay? And this is dealing with finding f of x, but it's just not a number inside, it's an expression, okay? We do it the exact same way, meaning if this is replacing what x is, we need to replace this x with x minus 1. So we do that with parentheses, okay? So just how they replace the x with the f of x and with the x minus 1, sorry, we're going to replace the x with the x minus 1 as well. Okay, and then we just go ahead and simplify. You're not going to get a single number. You're going to get a simplified expression for your answer. So I just go ahead and distribute out the negative 3. So I end up getting negative 3x plus 3 plus 12. And then I combine my like terms. So the f of x minus 1 is equal to negative 3x plus 15. That's all it is. It's just going back to simplifying algebraic expressions. So you're going to try this one on your own, okay? And we will go over it next class. But that's it for my video. So, yeah, I'll see you guys next class. Have a good weekend. Yeah, or you already had a good weekend, and I hope you had a good weekend because you're watching it the day before it's due. But either way, either have a good weekend, or I hope you did have a good weekend. Okay? Bye. Bye.